Dear students, Salam Alaikum. This is the video for experiment number 1, Measurement and Uncertainties for Physics 170L Introductory Physics Laboratory for the semester Spring 2020-2021. Every experiment will have two sets of videos. The first set will be from your lab with the apparatus and the actual experiment, and the second video will be based on my notes, which I just like to call as the theory video because it's from my notes in my laptop. And the experiment videos are from your lab with the equipment. And in this particular experiment, there are three small videos, part 1, part 2, part 3, and the theory video is what you are watching right now. Now, in this experiment, we'll be familiarizing ourselves with measurements and uncertainties. Most of the time in introductory physics laboratory, this is the first experiment where they learn to use certain measuring instruments and do calculations related to the error, which we write as plus and minus. Now we'll start with the example of a scale which is easy to understand, then we'll move over to other things. Now you have a picture of two scales here. In the first scale, the lines are marked 1 centimeter, 2 centimeters, and 3 centimeters. In the second scale, you have 1 centimeter, 2 centimeter, but each centimeter is divided into 10 lines. 1 centimeter is equal to 10 millimeters, so the least count is 0.1 centimeter or 1 millimeter. One line is 1 millimeter. In the second scale, in the first scale, the one line is 1 centimeter. Now, this is similar to what happens in your clock. In the clock, you can have two hands or sometimes three hands. The first hand will tell you about the hour. The second hand will tell you about the minute, and the third hand will enable you to know the seconds. Suppose there is no seconds hand, then you can only talk about minutes and not the second. You cannot say it is in the middle, it is 20 second, 30 second. You cannot do that. In physics measurements, it should be on the line. If there are no lines or less lines, then the situation changes. Here also, it is the same thing. In the first scale, you can measure only in centimeters. You cannot say, even if it is in the middle, it is 1.5 centimeters. It is wrong because there are no lines. You have to choose between 1 centimeter and 2 centimeters. The middle point you cannot take as 0.5 or 1.5 from your mind. You have to just look at the lines. For example, if you go to a shop, you have only 100 Beza notes. The shop also does not have any coins, only 100 Beza notes. Either he will take 100 Beza from you or 200 Beza. He is not going to cut the note. So here also we cannot put lines from your own mind. You have to just read the lines. See, the instruments come ready made. We have to read the lines on them. So in the first scale, we have lines after every 1 centimeter. In the second scale, we have lines after every 1 millimeter. Which is better? A scale which has more lines where you can see small and small. So here we have a concept of a least count. The least count is the smallest quantity which can be measured by an instrument accurately, is called the least count, LC, of an instrument. For example, in your clock or the watch, if there is no seconds hand, the least count will be 1 minute. If there is a seconds hand, the least count will be 1 second. If there are that many lines on the dial of the clock. In the first scale, the least count is 1 centimeter. In the second scale, it is 1 centimeter divided by 10, which is 0.1 centimeter equal to 1 millimeter. Some scales also have 20 lines, then you'll have 1 centimeter divided by 20. But it's difficult to draw more than 20 lines, so we have to do something different. We'll discuss it shortly. Now, look at the protractor. Protractor helps you to measure the angle, and this is half circle, this protractor. So it is 180 degrees. So it is divided into 180 degrees. So you can see it is 10 degrees, 20 degrees, 30 degrees. It goes on up to 90 degrees, then 180 degrees. So the least count here is 1 degree. We cannot say that it is in the middle. So we'll say 59.5 and or 60.5, you have to choose one number, either 59 or 60 or 61. So here it is marked 60 degrees and the angles are measured anti-clockwise. We'll talk more about angles in experiment number 4, not today. You just remember that the least count for an ordinary plastic scale is 1 millimeter, or sometimes half millimeter if it is divided into 20 lines. 1 centimeter by 20 is 0.5 millimeters. For the protractor, it is always 1 degree. It's very difficult to find protractor with extra lines, and you have to buy some special instrument if you want to measure small angles. And there are some other methods of measuring the angles with the help of a triangle. Now, what are the instruments if you want to measure less than 1 millimeter? There's many instruments. We'll be discussing two such instruments today. First one is called Vernier calipers, and the second one is called screw gauge. Screw gauge is also called as a micrometer. Now, what is important is all such instruments normally have two scales. Your clock has two or three hands. Here there will be two or three scales, and the two scales together will tell you the reading, which is less than 1 millimeter. So, one will be your main scale, and one will be a special scale. The special scale has a name depending on the instrument. So the main scale will be your millimeter scale. We can call it the imperial scale or the metric scale. Can give it any name. Now let's look at the vernier calipers closely. See, the main scale here will be just like your ordinary scale. 1 centimeter divided into 10 lines or sometimes 20 lines. It is 1 millimeter or half millimeter is the smallest you can do. Now the second scale is called the vernier scale, and this vernier scale moves over the main scale like this. There are other advantages of using the vernier caliper. What are they? You have the external jaws. This will help you to measure the outer diameter of a rod, of a bottle, or of a pipe. The rod does not have an internal diameter, but the pipes have, the bottles have. So the internal jaws will help you to measure the internal diameter. See, what is important here is there are two things. One is you can measure less than 1 millimeter, and you can also hold the instrument in such a way that you can measure the diameters very accurately. If you try to measure the diameter of a cylinder with a scale, the scale can move a little bit away from the diameter and the measurement is not correct. Here the measurement will be very good even if you don't use the vernier scale. If you use only the main scale, the jaw will hold the bottle in the right way and you'll get the correct diameter, even if you don't look at the vernier scale. Now this thing at the other end will help you for measuring the depth. This is a blade-like thing, long, so you can measure the depth of a glass or a beaker or a bottle. This is for internal diameter, for internal jaws and external jaws. So these are the advantages because the instrument will hold the object, the sphere or the bottle or the cylinder or the rod, and you'll get very good measurement because the jaws will hold the thing properly. So it has two advantages, the jaws for holding the thing, and the other thing is the vernier reading. The two scales will do. Now, what's the least count in a vernier caliper? It may not be written on the instrument. You have to calculate it. How do you calculate it? Look at the main division. The main scale, it is normally 1 millimeter, just like your ordinary scale. Now, just count the number of lines here. If it has 10 lines, you divide 1 millimeter by 10, you'll get 0.1 millimeter. If it has 20 lines, divide by 20, just look at the instrument and do it. Least count is normally not written. You have to calculate it for everything, every instrument. So much for the thing. We'll discuss this more in the lab video. Today we'll focus on the calculations rather than the instruments themselves. The instruments will be covered in more detail in the lab videos. There are two links here where you can see the animations of the vernier caliper, and you should know how to draw the vernier caliper for your lab reports and for your exams. You should know how to draw it by hand and write the main part. What are the main parts? The external jaws, the internal jaws, the metric scale. You should write main scale. and depth measuring blade. Just remember these things, draw a simple diagram and it will work. Suffice. Next thing is the screw gauge. The screw gauge again has two scales. What are the two scales? One is your main scale which you see on the barrel, and there's another scale here which you can see 0, 5, and here this is 45. There are 50 divisions. So what happens is there's a screw inside. When you rotate it one time, it will advance by 1 millimeter. And how many divisions we have here? Normally we have 100 divisions, sometimes 50 divisions. So it will be half millimeter. Here you can see it is half millimeter on the main scale divided by 50, and the least count is 0.5 divided by 50, which is 0.01 millimeter. Pitch is the height which you get by one rotation on the screw. Sometimes you'll have 1 millimeter divided by 100. Both are available in the market. Both have the same least count. Sometimes you have the least count is smaller than this. Smaller the least count, the better. With vernier calipers, you can measure the thickness of a paper, but if you want to measure the thickness of a thin hair, one needs the screw gauge. And there's a lock, you can lock it and take the reading after some time. Even a screw gauge, so both the vernier caliper and a screw gauge have a lock. After you take the reading, you can lock it and see it. In your digital instruments, you can save it. There's a memory to save it, the last reading, or sometimes more than the last reading. Again, there are two links to the animations. You please look at these animations on these links. Now, every experiment we have discussed how to write the lab report. There's an aim and there's the apparatus in the beginning, and there are other items also. What's the aim of this experiment? Today we are going to learn how to use a screw gauge and the vernier calipers. Scale everybody knows to use. Then what measurements we'll make? We'll make some geometric measurements that will help you to calculate the density of a sphere. The sphere is a round thing like a football in your geometry. You measure the diameter, you'll get the volume, you measure the mass, and mass by volume is the density. We'll discuss the formula again. Then you can also estimate the value of pi, the mathematical pi 3.1415. You can do it by measuring the diameter and the circumference of a disk. We'll discuss it in detail. What apparatus you'll need? You'll need pan balance to know the mass, vernier calipers, micrometer screw gauge, then steel ball, one rod, one paper tape, and steel disc. The first thing will be the measurement of pi. Now, we are not going to calculate pi like mathematicians, we'll be doing it in the physics lab. And originally, the Greeks had also done it like this. You measure the circumference of a circular disc. That round distance which you have of a circular disc is called circumference. You measure the diameter, and C equal to pi into D, pi equal to C divided by D. Now, when you enter the lab, you'll have an empty table drawn on your paper like this. You measure the diameter 5 times. In lab, every measurement is done 5, 10, 20 times, not one time. In mathematics, we do it one time, but in lab, everything is many, many times. In some labs, they take measurement hundreds of times. Measure the diameter 5 times and we'll do some calculations on this and then calculate the value of pi and compare it with the standard value of 3.14. We cannot take many numbers here because your instrument cannot see many digits after the decimal. So we'll also take only 2 digits from the value of pi, 3.14. I will just let us see how we do the thing. See, these yellow are the data which you will get from your lab. On the empty table, you'll just measure the diameter and the circumference. Now the circumference you are not going to use thread or a rope. You'll get a good measurement if you use a ribbon or a strip or a tape as they call it. You just put a tape around the disc, that will give you a better value in measurement. If you use a thread, it will not align well. The rope will also not align well, so the reading will not be good. The best reading will come by using a ribbon or a tape because both are flat. Now, yellow is what you see in the lab, and black are your calculations. In our lab, this is how we do it. Now you measure the diameter 5 times, 5.1, 5.0, 5.1, 5.1, 5.0. You are not going to get the same diameter every time. There will be a small difference. Sometimes you'll get all 5 same numbers, but usually you will not get it. If you get same numbers, the teachers will doubt your measurement. So just use the numbers which you get in the lab or which are given to you. Do not change the numbers. Now add all 5 of them. You have to find the average after you take many readings. What's the average of 2 and 3? 2 plus 3 is 5. 5 divided by 2 is 2.5. Average means mutawasat, the middle number. Not exactly middle number. It is in the center. It can be anything. For two numbers, it is exactly center. For otherwise, it's not exactly center. Add all 5 of them, you'll get 25.3 divided by 5 is 5.06 centimeters. Please write down the units all along. You have to be conscious what units you are using. In this lab, we'll be using centimeters because it is easy to calculate in centimeters in this lab. In other experiments, we'll be using meters and kilograms. Now calculate. This is your D bar. This line above means average. So D bar is 5.06 centimeters. Now calculate delta D bar. It is D minus D bar absolute value. See, all these quantities have to be positive. So we take the absolute value. What's the absolute value of 4 minus 2? Sorry, 5 minus 2 is 3. Absolute value is 3. What about 2 minus 5? 2 minus 5 is minus 3. But the absolute of value of minus 3 is plus 3. It is the mutlaq. You remove the minus sign and just take the positive part. So you take 5.06, you subtract 5 times and take the absolute value. 5.06 minus 5.1, or no, you'll do 5.1 minus 5.06, you'll get 0.04. 5 minus 5.06 will be minus 0.06. You take the absolute value, you'll get 0.06. Then take the average values of these D bars. Delta D bars, it is delta D bar average is plus or minus 0.048 centimeters. In a good experiment, all these 5 yellow numbers will be equal and delta D bar will be automatically 0. But that is very rare. Normally, it will not happen. Then you measure the circumference 5 times using a tape. Do not use thread or a rope or anything, or do not twist your scale. That's not good. You just measure it 5 times using a tape. You'll get these 5 numbers 15 point something. Take the average, you'll get 15.8. Then again do delta C bar with the absolute value. You will get again 5 numbers. You don't have to calculate 5 times because 3 numbers are repeating, so your calculation will repeat. Do it one time correctly. Again take the average of 5. Do not ignore the 0. Add the zeros. 0.1 plus 0.1 plus 0 plus 0 and plus this 0. Totally 5 things. 0.2 divided by 5 is 0.04. Now what's the value of pi? It is circumference divided by the diameter. Average circumference by average diameter will give you the average value of pi. That's why we have put a bar. 15.8 divided by 5.06, it is 3.12. What's the standard value of pi? 3.14 from your book. So now do this calculation. 3.14 minus 3.12 divided by 3.14 into 100%. We'll get 0.63%. In this experiment, the errors will be 1 or 2%, not much, because one cannot make a big mistake in measuring the diameter or the circumference. Now calculate delta pi. You have to calculate delta pi and write it as plus or minus. How do you do it? Take this formula pi equal to c by d. Use your differentials from your calculus 1. You'll get this formula. Pi equal to square root of delta d by d whole square plus delta c by c whole square. If you cannot do it from calculus, just memorize the formula. If you can do it from calculus, it is good. Otherwise, just memorize the formula. Do this calculation very carefully. You'll get plus or minus 0.0307. All these delta numbers are supposed to be very small. In under ideal conditions, they are 0. So this is one example for your pi calculation. Now we'll look at another example for pi calculation. The another example of pi calculation, the diameter is changing too big. The circumference will also become bigger in correspondingly. So this is the example 2 for the calculation of pi. Same table, only the numbers are changing. Here the diameter is 5, circumference is 15.8, here it is 7 and 22 point something. Now the 5 diameters are 7, 7.1, 7.2, 7.3, 7.1. Add all 5 of them, then divide by 5. The average value will be in the middle, which is 7.14. The smallest number is 7, biggest is 7.3. It cannot be less than 7, it cannot be more than 7.3. It will be in the middle of the smallest and the largest number. It cannot jump out. It cannot become less than the smallest, it cannot become more than the biggest. Largest. Okay, in mathematics we say largest, biggest is not a suitable word. You take the 5 circumference measurements and again calculate the average. You'll get 22.2. Then here you calculate delta d bar, then the average you will get plus or minus 0.088 centimeters for delta d bar. Do the same calculation, you'll get delta c bar equal to plus or minus 0.12. Let's look at how the pi looks in this calculation. Pi equal to C by D averages. It is 22.2 divided by 7.14. It is 3.11. Write only two numbers after the point because your vernier calipers and screw gauge cannot see more than two decimal places. Now the standard value is 3.14. Now do your error analysis. 3.14 minus 3.11 divided by 3.14 into 100. Do this calculation carefully. It is 0.95%. This time the error is more. Was last time it was 3.12, you were close to 3.14. Now you are further away from it. So the error is more. Last time it was 6.63%. Now it is 0.95%. But still it is not big. Then calculate delta pi using this formula, which you have to memorize, or calculate using your differentials. Now, what's the part 2 of the experiment? Part 1 is calculation of pi. There are two examples here. If you are very busy, just look at one example and try to understand. If you want, use the second example to understand better. And you should know how to do these calculations. Yellow is your data and black is your analysis and calculation. In your exams and in your lab reports, you will be asked to do these calculations. So please learn to use them, and nobody will tell you that pi is 3.14. You have to remember it by some method. Do not use 22 by 7. You have to use 3.14 in this experiment and nothing else. There are two solved examples for the calculation of pi. Use one example or both as you like, but understand this calculation. Some students want two examples, so I have kept two examples. Some students manage with one example, so it's up to you. Now the next is part 2. Again, the data will be given in yellow and you have to do your calculations. This is your empty table. You'll measure the diameter and everything else will be calculated. You'll be only measuring the diameter in this case and nothing else. And again, you have some formula here which you'll be using. Now we'll just look at them in detail. Now, what are you going to do in the part 2? In part 1, you estimated the value of pi or calculated it from lab data. In part 2, read here. Solved examples for part 2. In part 2, you are going to determine the density. Now, sometimes we say the thing is light, thing is heavy. In physics, we cannot say light and heavy. We have to give it proper definition and numbers. Now, density is mass divided by volume. You take a mass of an object and calculates its volume, and if you want, and density will come by mass by volume. Short form symbols are rho equal to m by v. This is not p, this is rho, rho. Now what you do here is mass can be measured by the digital balance and the volume will come from the geometry. If it is a cuboid, you'll have length, breadth and height. If it is cylinder, it will be diameter and height. If it is cone, it will be the diameter and the height, and things like that. But what about the sphere? Sphere has only one quantity, which is the diameter or the radius. So in the lab, we cannot know the radius because we don't know where the center is. So we have to measure the diameter. And in some situations, even the diameter is difficult to measure. So we do something else. We'll discuss that some other time, inshallah. Now you'll measure the mass using the digital balance and you'll measure the diameter either using a vernier caliper or a screw gauge. If the ball is small, the sphere is small, you can measure with the screw gauge. If it does not fit in the screw gauge, you are going to use vernier calipers, but you are going to measure one diameter by one method or the other. Then calculate the volume of the sphere. What's the formula? V equal to pi by 6 d cube. If it is radius, you will be using 4 pi by 3 into r cube. If it is diameter, it is pi by 6 d cube. Repeat the diameter measurement 5 times. These yellow are your diameter measurements and the mass is given here from the digital balance 42.5 gram. What the error in the mass measurement? Delta m is plus or minus 0.02. This delta m you don't have to calculate, it is written on the balance for you. Digital balances, the delta is written on it, whether it is vernier calipers or screw gauge or whether it is mm, balance or something else, the delta will be written on the balance. Just read it in the correct units. Sometimes the mass will be in grams and the delta m will be in milligrams. So just make sure that you are using the both the units are same and the correct units. To measure the diameter 5 times, it is 4 point something, take the average. The biggest number is 4.6, smallest is 4.53. So without calculation, you know it is between 4.6 and 4.53, it is 4.56 if you add all 5 and divide by 5. Then do delta d bar 5 times, you'll get this positive number, take the absolute value. Do not forget the absolute value. And the average of delta d bar is plus or minus 0.024, again centimeters. Remember what units you are using. Now mass is 42.5 gram, delta m is plus or minus 0.02. Now the volume is pi by 6 d cube. Since we are taking the average d, the volume is also average automatically. It is 49.65 centimeter cube. And the rho, the density is mass by volume. The mass is 42.5 divided by 49.65. You'll get a number less than 1, which is 0.86 grams per centimeter cube. Now, if you want to calculate the delta rho bar, use your differentials from your calculus 1. Otherwise, memorize the formula. You'll have rho into square root of 3 delta d by d whole square plus delta m by m whole square, and remember to take the square root after putting all the numbers. You'll get plus or minus 0.0135 grams per centimeter cube. This is how you'll do your calculations, and the measurement of the diameter you can do with a screw gauge or with a vernier caliper in the lab. Now, what's the density of water? The density of water is 1 gram per centimeter cube. You might have heard the word cc. Cc means centimeter cube. The word cc is normally used in the engines and in the hospital. Hospital will say 1 cc of blood. That means 1 cubic centimeter of blood. Cc is your in your engine. If you look at your motorcycle, they'll say 100 cc motorcycle. It means the inside part of the engine where the petrol is going to burn has a volume of 100 cc. You are not burning 100 cc of petrol. You are just having an a volume where the petrol is burned with the help of your spark plug. Talk to more about it to your engineers. I cannot tell you more in this video about the cc of the engine. About the blood, yes, I can tell. Now this was your first example 1. Now let's look at example 2. Example 2, the diameter is changing, the mass is also changing, and the delta m is also changing. Why delta m is changing? Because we have changed the balance. So please do not think that delta m is plus or minus 0.02. It will keep changing from balance to balance, from model to model, company to company. And the mass depends on the object, not on the model of the balance. So take the diameter 5 times. In the example 2, take the average. It is 3 point something, so the average will be also 3 point something. Now calculate delta d bar using this absolute value of d minus d bar 5 times. You'll get some small numbers here. Take the average of those 5 numbers. It is 0.0072. Now calculate the volume. The average volume is pi by 6, average value of d cube. Average value of d is 3.254. You calculate the average. It is 18.04 centimeter cube. Now the mass is 90 point something and the volume is 18 point something. Your density is how much? Mass by volume. It is 4.99, very close to 5, but do not round off. Now calculate delta rho bar. Delta rho bar is rho bar into square root of this thing. 3 delta d over d whole square plus delta m over m whole square. Do this calculation. Delta m is here. Delta D you have calculated yourself. Diameter you know, average diameter, you know the average value of mass is 90.1. This is it. This is what you have to do, and the error is plus or minus 0.0332. These delta numbers are very small. So what did we do today? Today we looked at the vernier calipers and the screw gauge and the two types of scales with the least count 1 centimeter and 1 millimeter respectively. We talked a little bit about the three hands of the clock, two scales of the vernier, two scales of the screw gauge. Then we saw how to calculate the value of pi in a lab. You can also do it in your house with the help of a circular disc, and how to calculate the density. One time the density was less than that of water, one time it is 5 times that of water. And now about your lab report. In your lab report, and this part 3 we are not going to do, so don't ask me any question about this part 3. We have not done it, so do not ask me about it in this notes, but I have to keep it. Next semester we'll try to do it, or at the end of this semester we'll try to do it. Now these are your references. PASCO instructional manual. Please go to the PASCO website and have a good look at this manual. Second one is your physics book, Raymond and Survey, which you can use for physics 100, physics 170, physics 210, both the lab and the theory you can finish in that. This is the Moodle website where you'll find our physics notes, and this is a very good website for physics, physics.org. Go through it. Now you have to make a report. How will you make the report? In the report, there are two types of report. One report will be one page of theory, just write theory without any pictures and formulae, just the theory, one page. I have uploaded the sample in the Moodle, and I'll also upload an empty page. You have to write the theory in 250 words or even 200 words are sufficient. Type it in using MS Word, and I want the MS Word file, no PDF, nothing. And your one page theory will be checked with Turnitin. Then you'll have your full report. The full report will be aim, apparatus, figure, procedure, description, and your data analysis and the results. Now, what are the results today? The value of pi with the error plus minus, value of the density plus minus. Now, what about the diagrams? Diagrams you have to do with your own hand. No pictures, no cameras. You should know how to draw your physics diagrams. Draw them in a simple way and put the names of all the parts there. Now, what about the lab data? The lab data is given to you here. 5 diameters and 5 circumferences are given. Now you have to calculate the value of pi from this, the way we have done two examples in part 1. So this is your lab data, and you have to fill them with your calculations. Please do the calculations outside the table. The table should look neat the way I have done it. Yes. Now part 2. Part 2 is about density. Part 1 is about the calculation of pi. Now part 2 is about do the data analysis for the following data. You have 5 diameters, you calculate the volume and you calculate the density. And submit the report in time within a week. Both the one page theory and your long full report. This report does not have any graph, this experiment, but some experiments will have graphs and other things. So see you soon inshallah in the class. If you have any questions, ask me at that time. Thank you. Assalamu alaikum.